Some A-level students were given the following question. Solve for minus 90 degrees is less than theta, which is less than 90 degrees. The equation cos theta is equal to 2 sine theta. The attempts of two of the students are shown below. And question A is asking us to identify an error made by student A. And we can see what student A has done is cos theta is equal to 2 sine theta, and so tan theta is equal to 2, and therefore theta is equal to 63.4 degrees. Now, we can see that between lines 1 and 2 of the students working, that they have attempted to divide both sides by sine theta. And the way we can assume that is because on the right-hand side, we've gone from 2 sine theta to 2. And the way you'd get this would be dividing both sides by sine theta. So this means that they've assumed that cos theta, this is on the left-hand side now, that cos theta divided by sine theta is equal to tan theta, because they started out with cos theta, and then if we divide both sides by sine theta, and then they have ended up with tan theta. However, the equation for tan theta is actually sine theta over cos theta and not cos theta over sine theta, so they've got the equation the wrong way round. And so we can say that it should be sine theta over cos theta is equal to tan theta. Student B gives theta is equal to minus 26.6 degrees as one of the answers to cos theta equals 2 sine theta. And question BI is asking us to explain why the answer is incorrect. Now, if the question is only asking why, this means we don't need to actually provide any kind of reasoning other than that we just need to show that it's incorrect. And so to show it's incorrect, we can just substitute theta equals minus 26.6 into the equation. So if we take the left-hand side, which is cos theta, if we use theta equals minus 26.6 degrees, we put this into our calculator, we get that cos of minus 26.6 is 0.894 to 3SF. And then if we take the right-hand side, which is 2 sine theta, and put this into our calculator, we actually end up with minus 0.896. Now, as you can see, these two numbers that we ended up with are different, and therefore cos theta is not equal to 2 sine theta, and therefore the answer is incorrect. So for part II, we're asked to explain how this incorrect answer arose. And to find this, we need to look back at student B's working to see what they did. So they started out with the equation cos theta equals 2 sine theta, and then they squared both sides to get cos squared theta equals 4 sine squared theta. And then, because of the equation, or the identity rather, sine squared theta plus cos squared theta is equal to 1, they replaced cos squared theta with 1 minus sine squared theta, because you can just rearrange that. And then they added sine squared theta to both sides and divided by 5, and then square rooted and used a calculator to find that theta is equal to plus or minus 26.6 degrees. And we've just found that this answer is incorrect in part I, and we've shown this. But to explain how, we need to look at this line of working here, right up at the top where they squared both sides. And the problem with doing this is squaring both sides of an equation when they weren't originally squared introduces an extra solution. And a good way to think about this is if we think of a number, so for example 5, if we say that x is equal to 5 and then we square it, so x squared is equal to 25, and then we square root it, which you would think is just the reversal, you now get that x is equal to plus or minus 5, which it isn't, because we stated that x was 5, but we've introduced an extra solution of x is equal to minus 5. And here, this seems to be the problem as well. And so we can say that the incorrect answer arose from squaring.